Well, how's everybody doing out there? Well, welcome to day 6 of Corona Online School. So, last week we finally finished up chapter 2, so now we're moving into chapter 3, which is our probability section. So, I really love probability. I think it's a lot of fun. I know some people don't necessarily like probability, so hopefully by the time this is over, you'll really, really like it or at least not hate it so much. But it is kind of cool. Like, probability occurs in lots of different situations. I mean, it basically involves kind of fractions, percents, and things like that. But it's a nice way to predict again. Like the whole point of statistics is we're trying to use like samples to predict something about a bigger population, and so probability is a really really good way of actually doing that. So let's start off with a little bit of definitions just to make sure we've got the background behind it first. So, what is probability? So, probability is just a way of describing how certain we are of the result of a particular experiment or activity. And the probability of something occurring, it's defined as the proportion of times or the fraction of times that it would occur if we repeated the experiment over and over and over. And so we'll actually demonstrate that in a little bit so you can kind of see that live and in person. All right. So some of the things that we need to know for this are an outcome. So an outcome is one possible result of an experiment. So for example, if our experiment was flipping a coin, then in that case there's only two possible outcomes. It could either be heads or it could be tails. The sample space, so that's the list of all possible outcomes that can occur. So in the flipping of the coin one that we were talking about, since there were only two possibilities, heads or tails, then what we would do is kind of write that in this set notation and say S equals, curly brace H comma T. So in this case it'd be so, or for example, in this situation, if we roll a six-sided dice, the sample space would just look like, a die roll of 1, a die roll of 2, 3, 4, 5, and 6. So that would be all of our possible outcomes that we would get from rolling a six-sided die. So some other things that we can do is we can create a tree diagram, which gives us a nice way to visualize the events that could occur, but it also gets to tell us what order they would actually occur in, which is kind of nice. And then for you guys that I had in Math 110, you could draw a Venn diagram, which came from set theory, which I know you guys love so much. So we will do a little bit of that stuff kind of later also. And so finally, the last little definition that we need is the event. So an event is the outcomes from doing our experiment. So for example, if you roll a six-sided die, here are some possible events. So we could see what's the probability of rolling a 4, what's the probability of rolling an odd number, or what's the probability of rolling a number greater than 2. And then we'd have to figure out how to calculate all of those things. So all right. And so again, the way we actually write like the probabilities, so the probability of an event A occurring is written as P parentheses A, or you could actually write out the whole thing, probability of rolling a 4, or if it makes sense in the context, you could actually write it as just P of 4 in that case. So what we want to do first for the first couple examples is just kind of go through and write down what the different sample spaces would look like, and then we'll get to actually calculating the probabilities in a little bit. So imagine we flip two quarters. So we're going to flip one quarter two times in a row. So I guess we're actually flipping just one quarter. Or you could flip like two different color quarters or something like that if you want to think about it that way. But the main thing we want to distinguish is between the first flip and the second flip. So a lot of times when you write like these things down, you'll write, we'll do the set notation, but then we'll also write them in kind of ordered pair form. So the way I want to think of this is the first flip is going to be, the first part of the ordered pair, and the second flip will be the second part of the ordered pair. So again, we know for a quarter that we only have two choices, heads or tails. So what could happen is we could get, on the first flip, I flip a heads, but then on the second flip, I also flip heads. So I could get heads and then another heads. Or I could have flipped heads first and then flipped a tails for my second. So that kind of exhausts the heads possibility first. So that's kind of the way I like to do these. I like to like kind of fix one of the coordinates, go through all the possibilities, and then fix that first coordinate again with the other possibility, and then go through all the different possibilities. So in this case now, let's start with tails. So I could have a tail and a head, or I could have a tail and a tail. And so it turns out that's it. There's only those four possibilities that can occur if you're flipping 2/4 in that case. So there were two choices, heads or tails, four possible outcomes. So kind of keep that in mind. All right, so what if I increase this now, and now I flip 3 coins in a row? So again, I still only have two choices. It's either heads or tails. But because I'm flipping 3 coins in a row, now I'm going to need what's called like an ordered triple, in this case, to write things down. So I'm going to get first flip for the first position, second flip for the second, and then third flip for the third. And so again, I'm going to do the same thing. I'm going to kind of like go, start with heads in the first position and then try to cycle through all the possibilities of what could occur in those other positions. So in this case, I'm going to start off with, so I could have heads in all the positions. And so what I'm going to do is I'm going to fix the first and second positions and then go to switching the third position. So that case, that's kind of taking care of the two heads first because I've gone through all the different possibilities. So now let me just leave this first one as a heads and then put a tail there. So now I can get either a head next, or I could get another tail. So in that case, that's actually taken me through all four kind of possibilities of what I can get, starting with heads first. So now let's kind of do the same thing. Let's start with all tails, say. And then again, I'm going to fix the first two tails and write that as tail, tail, head. Now I've used all the possible like first two T's together. So now let me just fix this T, then a head. And so again, I can have either a tail, or I can have tail, head, head. And so in this case, with 3 flippings of coins, I've got 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 possible outcomes. And so the thing to kind of notice is, notice when I had 2/4 I was flipping, I had 4 outcomes, which is the same thing as 2 squared. And when I had 3/4, I had 8 possible outcomes, which is the same thing as 2 to the third. So the idea is, if you increase the amount of coins, so if I went up to 4/4, then I'd end up with 2 to the 4, or 16 possible outcomes. If I went to 5/4, I'd end up with 2 to the 5th, or 32 possible outcomes. So it kind of increases exponentially as you add an extra quarter. So just kind of keep that in mind if you'd have a problem that looked like that or something. All right, so those are 2 possible sample spaces. And again, keep these in mind. We're going to use these over again, so that way, like, it'll be worth the effort. So make sure you write these guys down, so that way you don't have to recreate them every time you're asked about a 3/4 problem. You can just go through your notes and immediately jot down what it looks like. So example 3, this is another one that's a good example for drawing a nice sample space, because it's a little deceptive. Oops, this should be a black die. A little typo there. It's a little deceptive what you might think. So in this case, we're rolling 2 dice. So one's going to be a black 6-sided die. One's going to be a white 6-sided die. And so if I asked you without even like knowing anything, like, what do you think? How many elements do you think we might have? So more than likely, a bunch of you at home are probably saying 12, which is usually the answer I get. And it's actually not correct. So it turns out that there's actually going to be 36 outcomes. Because the idea is I've got 6 choices for the first position, and I've got 6 choices for the second position. So in this case, I'm going to get 36 possible outcomes that I can get. So the way I'm going to write these down, again, are going to be a big list of ordered pairs. So I'm going to put the black die first and the white die second. And so again, I'm going to do that same kind of trick I did above by like fixing a position and then kind of running through all the possibilities. So in this case, I'm going to have a humongous set here, so I might as well go and make a bunch of room. So I'm going to go ahead and fix the black die to stay 1 for this whole thing and cycle through all the different white die possibilities. So in this case, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. So that's every single possible black die number 1 paired up with every possible white number. So now start over again and start with the black die number 2. And then again, just cycle through all the different possibilities. And that takes care of all the different possibilities for black die 2. And then just keep doing this over and over for black 3, black 4, black 5, and black 6. So I'll just start writing them down, so we don't bore you to tears here. But these are important because it's nice to have these sample spaces written somewhere, because the last thing you want to do is have to recreate these every single time, because again, these are really good problems that you can get asked questions about. So it's nice to have easy access to the information. So again, write this in your notes, keep it somewhere where you know it's at, because it will come up again. Shoo. So there's our big sample space, again, of 36 different possibilities that we can have. So again, that's all for sample space right now. So again, it's just a way of writing out all the different possible outcomes that are there. So just kind of be careful when you're writing them out that we don't miss anything. So now let's actually get into how do we calculate probabilities. So in this case, we're going to need some rules first. So some of the main rules of probability are that all probabilities always live between 0 and 1. So again, remember, these are proportions or percentages. So we can't have a probability that's negative, and we can't have something that's greater than 100% is the idea. So worst case scenario, we get 0, which would be number 2. So if we get a probability of 0, then that means that no matter what happens, that event can never occur. So for example, the way to think about that is if you had a 6-sided die, and I said, what's the probability of rolling a 10 on a 6-sided die? Well, there is no 10. So it's impossible for me to roll a 10 on a 6-sided die, so that's never going to happen. Where, on the other hand, the probability that A always occurs would be a probability of 1. So again, if we think about a 6-sided die, if I said, what's the probability of rolling a number less than 8? Well, that's always going to happen because, I'm always going to roll a 1, 2, 3, 4, 5, or 6. So no matter what I roll, it's always going to be less than number 8 in that case. So that probability is going to occur all the time. And then it turns out if you take all the events together and add them up and sum their probabilities, that probability will actually equal 1. So that's what this means in this case. So if you think about it this way, like the probability of like rolling flipping a coin, would be say 1 out of 2, and so heads would be 1 out of 2, tails would be 1 out of 2. If I add these guys up, I end up just getting 1. So that's what that last statement means, that if you take all the possible outcomes together, add their probabilities up, then that'll give us a total of 1. And so this just gives you a little summary about how probabilities show up everywhere. So this is the most important one. This is the one I'm hoping actually happens, that there's a 95% of chance that everybody in class earns an A. That would be pretty awesome. So let's shoot for that if at all possible. All right. So next what we want to talk about are the 2 different types of probabilities. So there's empirical probability and then there's theoretical probability. So empirical probability is where we actually observe something. So like we actually flip a coin, we actually roll a die, we actually ask people a question. So that's where you're actually actively involved in the process. And so based on your observations, the flipping, the rolling, whatever, you're trying to figure out what these probabilities will actually be. So to actually compute an empirical probability, what we would do is actually take the observed number of times that E occurs, the event occurs, divided by the total number of times that we rolled the die, flipped the coin, whatever it would happen to be. So unfortunately we're not in class, so we can't do this in person, but I thought we could still do this at home and then like pull all of our results together. So this will actually kind of be the collaboration where we kind of pull everybody's results together and see how close we get to what we think, flipping a heads would actually be. So in this case, what we're going to do is actually, toss a coin one time. So in that situation, since we're only flipping it one time, you're only going to get either a heads or a tails. So for this one, you're either going to get 0 over, or well, don't do hitting the wrong thing. So in this case, you're going to write either a 0 or a 1 because it either was a heads or it was a tails. And then your probability is either going to be 0 over 1 or 1 over 1. So in this case, it's going to be a weird situation because you're either going to get a 0% or 100%, which we know really doesn't reflect, the actual, flipping a coin and stuff like that. But hopefully, as we do more and more trials, we'll get better and better and better. So then start over again. Now this time flip 5 coins. Again, tally how many heads you had, and then divide that number over 5. And then start over again from scratch, flip it 10 times, tally all the heads in this side. Then whatever we're going to get, we're going to divide that by 10, and then just keep going. So start over with 20, start over with 50. And then eventually what we're going to do is we're going to put our total in the collaboration space, and then I'll kind of go through, or if a student wants to go through and kind of add all those up for me, then we can figure out like what our class total was and see how close we think we get to the middle. So you probably have an idea of what you think it would be. You probably think it would be 50%, which would be correct. Like that's what we're actually shooting for. So down in these two boxes, hopefully the probability of flipping a heads would be about 50%. So at this point, pause the video, take a little break, flip some coins, be careful, don't poke anybody's eye out as you're flipping coins. It's usually pretty dangerous in class. So, and then when you're done flipping your coins, recording your results, and posting it up on the collaboration space, come on back and then we'll do some other empirical probabilities here. So, all right, so very good. So at this point, like I said, hopefully you've posted your collaboration, you've got some good results. Hopefully even at 50 coins, you saw that it was getting pretty close to 50%, even though it may not have been at 5, 10, 25, and things like that. So another cool way that we can actually use empirical probability is by random sampling like a population or a sample, that if we break it down by group. So in this case, the first practice I want you to look at is these are FCC students and the reason they're attending FCC. So this is like actual enrollment data stolen from FCC. So we've got degree-seeking students, so that would be if they're getting an AA, an AAS, an AAT, an AS. So any of the kind of 2-year degrees, they'd be falling into that category. Then we've got the certificate-seeking students. And then finally, the course of interest students. So they're just the students that, maybe just taking one class, or they could be a dual enrollment student taking a class or something like that. So they haven't actually figured out a major or anything like that. So what we want to do is, first off, like notice I left a box down at the bottom. So I'm going to leave this for you guys to work on. But we have to know the total, because remember, whenever we're doing our probability, go back to our empirical probability, we need to know the total number of observed occurrences that exist. So we already have the top number. So in this case, this is the observation. So we know that there's 4,226 students enrolled that are degree seeking. So that's going to be our top number. So that's going to be the same for all of these guys. That's going to be the top number. And then whatever our total is, that'll be the bottom number for these guys. So go ahead and work on practice 2. Practice 3, again, is the same kind of idea. So again, this is enrollment data from FCC of students broken down by diversity. So if you want to go through and work on those on your own, pause the video, and then when you're done, come on back, and then we'll talk about what theoretical probability is. All right. So hopefully you did good on those. If you did have any questions or anything like that, definitely ask. So the main thing to make sure with those empirical problems like that is to make sure you always find the total. So because if you don't find the total, we're going to be in trouble from that point on. So theoretical probability is kind of what empirical probability, especially in that flipping of coin situation, it's what we would expect the probability to be. So again, when you're talking about flipping a coin, there's only 2 possibilities. You can either get a heads or you can get a tails. So in this case, the probability of getting tails, since there's only one way to flip a tail, but there's 2 possible outcomes, gives me a 1 over 2 or a 50%. So again, the theoretical, we don't have to actually go through and try things. We don't have to roll the dice. We don't have to flip the coins. We just use what we think should be true. So again, this kind of assumes you're using like a fair coin or a fair dice or something like that. So there are things called unfair dice or unfair coins where they're weighted funny so that they actually roll more towards another number than they should. So everything we're going to do, we're going to assume everything's fair and that everything's going to be perfectly fine. So let's kind of look at an example 4 here. So in this case, we're rolling a die. And so if you remember, the sample space for this was just you could roll a 1, 2, 3, 4, 5, or 6. And so what's the probability of rolling a 4? Now be careful here because I see a lot of students make this mistake. They'll put 4 over 6 because they see the number 4 there. But remember, when we look at our sample space, how many times does 4 actually appear in our sample space? Just once. Yeah, exactly. So in this case, we're not going to get 4 over 6. We're just going to get a 1 over 6. And so for now, I'm going to leave these as fractions. So feel free, if you want to, go in and turn these guys into decimals and stuff like that. But for me at the moment, I'm just going to leave them at fractions. But again, you can do 1 divided by 6 and turn these into nice decimals and percentages and all that stuff. But for right now, I'm just going to leave these as fractions. All right, so now let's look at an even number. So if we want to find the probability of rolling an even number, then the first thing we need to do is look through our list and find out how many even numbers are in our list. So in this case, the probability of an even, so I guess I should have wrote over here probability of a 4, sorry. So a probability of an even number, so notice I've got 3 numbers that are colored in orange, 2, 4, and 6. So those are our 3 even numbers. And then of course, how many total numbers were there all together? There were 6. So 3 over 6 equals 1/2. So again, this would be 0.5 or 50% if we were to simplify it down. All right, so let's look at C. So in this case, a number greater than 10. So if I look through my sample space, are there any numbers greater than 10 in there? Nope, none at all. So in this case, so my probability of something greater than 10 is just going to be a 0 on top because there's no numbers that are greater than 10. So again, divided by 6 tells me that my probability of this occurring is 0. Because again, no matter how many times I roll a 6-sided die, I'm never going to get a number 11, 12, 13, any of those guys. So similarly, if I'm looking for a number less than 20, so am I always going to draw a number less than 20? Yeah, I mean, I'm not going to get 19, 18, 17. I'm not going to get any of those, but 1, 2, 3, 4, 5, 6 are all smaller than 20. And no matter what I do, I'm always going to roll one of those. So I'm going to always roll either, one of those 6 numbers. So I've got 6 possibilities for the top. There's total number is 6. So again, 6 over 6 just gives me 1 or 100% in that case. All right. Does that make sense to everybody? All right, very good. If you have any questions, definitely don't hesitate to ask. So feel free to ask me. So now let's look at that 2/4 situation again. So again, this is using that sample space example we did at the beginning that had sample space 4. So I'm just going to jot those back down again just so I can have them to look at once I find where I was at. Here we go. So let me write my sample space down again. So I had heads and heads, heads and tails, tails and heads, and tails and tails. So for all of these, no matter what I get, I'm always going to get 4 as my bottom number. So that's one thing you can always do. Like once you find out what the total sample space is, if you want, you can just go ahead and fill that out right away. So that way every bottom number is always going to be 4. So in this case, the probability of flipping 2 heads. So in this case, that's just going to be this one situation. So I had heads on the first flip, heads on the second flip. So there's only one way that I can get 2 heads. So in this case, I've got 1/4 or 0.25 or 25% is going to be the probability of getting 2 heads. So what about, oops, didn't mean to erase everything there. So what about the probability of getting 1 head and 1 tail? So in this case, even though they're ordered differently, that still gives us that same combination. So in the first situation, I got a heads first and then a tail. Second situation, I got a tail first, then a head. But either way, I got 1 head and 1 tail. So in this case, there's 2 possibilities of getting 1 head and 1 tail. So in this case, I'll get 0.5 or 50% would be my answer for this. So the probability of getting 1 head and 1 tail would be 50%. All right, so let's see if I can get rid of this without erasing everything. Good. All right, so now what's the probability of at least 1 head? So at least 1 means I got 1 head or 2 heads in this case. So that means I want to get these guys and I want to get this one because in this case I've got 2 heads. So really I'm just looking to make sure I don't want to choose anything that has all tails. So in this case I'm kind of ignoring the 2 tails one at the end. So in this case, I've got 3 possibilities that have at least 1 head. Oops, got the highlighter going on here. So I've got 3/4 of a possibility or a 75% chance of getting at least 1 head in that case. All right, so finally, let's erase these. And so the last thing is, what's the probability of getting no tails? So in this case, I don't want to get any tails at all. So anything that has a tail in it, I actually want to ignore. So I'm actually going to go through and strike out the ones that have tails in them. So I don't want that one, I don't want that one, and I don't want that one. So the only one I do want is this one in blue, because it's the only one that doesn't have any tails in it. So in this case, there's only one way to flip a coin that gives me no tails. So in this case, 1/4 gives me, again, 25% or 0.25. All right. So any questions or anything about that one? All right, very good. So the next one's practice one for you guys to work on. So if you're not familiar with cards, I've given you a deck of cards to kind of lay out here so that way you can kind of go through and see what's going on. So each card has different suits. So again, if you're not familiar with them, so these would be the clubs. These would obviously be hearts. These would be spades. And again, these would obviously be diamonds. So notice there's 52 cards total. So it's broken down into kind of 4 sets of 13. So there's 13 clubs, 13 hearts, 13 spades, and 13 diamonds. And then there's these number cards. I said one thing, is face cards, I mean. So the guys with faces are what are called face cards. And so if you count, there's 12 face cards. And then the number cards are obviously the ones that start with 2 and end with 10. So the one with the A on it's what's called an ace. So I don't actually count that as a number card. I know some games count it as a number, but in this case I kind of think of it as its own separate card. So there's 4 aces in the deck, as we can see just by counting those. and then number cards and stuff like that. So if you've never played cards or anything like that, hopefully the little picture will help you. Definitely ask me questions if you're confused about any of them. And then practice 5, I have you guys doing the 3/4 example. So first thing you'd want to do is write down that sample space of 8 elements. So go do that and then answer some questions about those. And then practice 6, so I actually laid out all 36. So this is the same one we did where we had the 36 different combinations of die rolls. So again, we've got the black on the left, the white on the right. So again, go through, answer some of these guys. And again, if you have questions about them, let me know. And then the last couple here, so we've got, or the last one is a marble one. So again, we've got marbles that are different colors, and so we want to draw out the probabilities and see what we get. And so again, unfortunately, we're missing out on this. So I always like to do a little quality control testing of M&Ms, and there may be some stuff in here that you didn't realize about. And so I summarize it in a little document, but to go through, like basically M&Ms are produced at 2 different plants, Hackettstown, New Jersey, and the Cleveland, Ohio plant. And surprisingly, like the plants actually put out different distributions of M&Ms, like they have different color distributions. It's not the same at each one. So normally at this point I would pass out M&Ms to everybody, give everybody their own bag or two of M&Ms, and we'd kind of count them up and try to figure out whether the probabilities that we actually chose in class actually, came somewhat near approximating what they actually say the proportions would be. So, and I wrote down at the bottoms what those proportions are. So for us, typically, like on the East Coast, it seems like most of our stuff comes from the Hackettstown plant. So the numbers that we would get would normally model those numbers closer than anything else. Like I've yet to see a Cleveland M&M, so I assume that's kind of a Midwest, West Coast type thing. So if you guys are up for it and you want to actually go and buy your own bag of M&Ms, I can actually make this as a nice collaboration also. I don't want to force anybody to go buy M&Ms or anything like that because I would normally provide them. But if you want to do it, I'll make the table and all that stuff available so everybody can kind of fill in their own data. And then again, we can kind of pool all of our information as a class and see how close to the actual probabilities we came. So these down here would be the theoretical probabilities, and then what we would be calculating would actually be the empirical probability. So again, this is kind of a cool assignment that we do in class. Unfortunately, since we're not together, we can't do it. But again, if anybody's game and wants to buy a pack of M&Ms and conduct this, I'll set it up as a collaboration, and anybody who wants to participate can. If you don't want to buy M&Ms, that's fine too. But all right, so that's 3.1. So that's kind of the basics of probability. There's a lot of stuff going on there. There's a lot of good practice for you guys to work on. Let me know if you have any questions or anything like that. And otherwise, I'll have the 3.2 video ready to go when you are. So see you later.